Welcome back to the deep dive. So you've spent, the last 6 months really getting into Python. You built some pretty incredible customer support chatbots, I hear, and you've really mastered prompt engineering. You've definitely seen the power of AI, the raw potential. But what if I told you there's this whole other level, a whole new frontier of autonomy, of intelligence just waiting for you, a place where AI isn't just, spitting back responses based on your commands, but where it's actually reasoning, planning its own steps, and then, executing complex multi-stage tasks all on its own. Today, we're going to unlock the world of agentic design patterns. Think of this as like your essential mental map for building the next generation of AI solutions. We're talking systems that aren't just smart, they're truly self-directed.
Exactly. And our mission today in this deep dive is really to break down these new key concepts. We need to unpack the crucial technical terms, the architectures behind these agentic systems. We really want to make this learning curve feel smooth and intuitive for you, providing thoughtful questions, structured explanations, just really equipping you to take that crucial next step in your AI journey.
Because we know you're not just building this stuff for fun, right? You're building to make a real difference. And specifically, you're looking at how to creatively and efficiently support domestic violence crisis response organizations using AI. Just imagine the impact, the profound impact of truly intelligent, autonomous agents in those critical high-stakes situations. Agents that can not only process information, but act on it intelligently with empathy and precision. Okay, let's unpack this. Let's see how we can get there. Okay, so let's start our journey with something pretty groundbreaking, I think, especially if you want to leverage AI agents without immediately, diving headfirst into really complex code. AgentSpace. Now, you might initially think, oh, okay, just another platform for chatbots. But AgentSpace is, it's profoundly different. It's designed to facilitate what people are calling an agent-driven enterprise, which basically means it integrates AI directly into the daily, often complex workflows of an entire organization, not just, sitting at a conversational interface. At its core, AgentSpace gives you this unified search capability, and it spans across an organization's entire digital footprint. Imagine being able to search through all your documents, emails, internal wikis, databases seamlessly, all from one central intelligent access point. And this is way beyond a basic keyword search. It uses advanced AI models like Google's Gemini to truly comprehend and synthesize information from these incredibly varied sources. So the AI isn't just finding matching words, it's understanding the meaning, the context, the relationships within the content.
That's a really critical distinction right there. From what you're describing, it sounds like AgentSpace immediately elevates the whole idea of an AI assistant. From just a reactive chatbot, which basically sits there waiting for your command, to something proactive, an autonomous entity. So this isn't just about faster searching, is it? It sounds like it's about an AI that can actually orchestrate complex workflows without constant human prompting. What are the immediate tangible benefits you see for an organization when AI moves from merely responding to proactively managing tasks?
Yeah, that's a great question. And it really gets to the heart of why AgentSpace feels so impactful. The tangible benefit is this fundamental shift in, operational efficiency and problem solving. These specialized AI agents, they're not just chatbots, not at all. They can do far more than just answer a query. They can reason, meaning they interpret goals, understand implications. They can plan breaking down complex objectives into multi-step actions. And crucially, they can execute those actions autonomously. Let me give you an example. An agent you build in AgentSpace can be tasked with something like research the latest legal changes affecting domestic violence protections in our state. It wouldn't just spit back a list of links. No. It would research, synthesize the information, compile a comprehensive report, complete with accurate citations from various sources. And then here's the really autonomous part. It could even generate an audio summary for a team debrief, or maybe automatically update an internal policy document based on its findings. This is a world away from a simple bot that just pulls up a document. It's an intelligent entity performing a full workflow. Okay, so to achieve this level of intelligence, this contextual understanding and autonomy, AgentSpace constructs something called an enterprise knowledge graph. Now, that isn't just some fancy term. It's a dynamic, interconnected map. It precisely outlines the relationships between people, documents, data points, even concepts within an organization. Imagine a super intelligent librarian who not only knows where every book is, but understands how every author, character, theme, and event in every single book connects to every other one.
That's a fantastic analogy, really captures it. So essentially, instead of just having isolated data silos, the enterprise knowledge graph creates this unified, almost semantic understanding of the organization's entire information landscape. What makes this so critical for the agentic nature of these AI systems? Beyond just getting better search results, how does it enable that reason, plan, execute capability we were talking about?
That's exactly it. This knowledge graph is absolutely critical because it provides the AI with deep context, rich context. Without it, an AI might just see every piece of information as isolated, disconnected. But with the graph, it sees the bigger picture, that intricate web of connections. And this allows the agent to deliver far more relevant, personalized, and crucially actionable results. Because it understands the full environment it's operating within. It's really what allows it to reason effectively. Think about the incredibly complex web of information within a domestic violence crisis response organization. I mean, it's huge. You've got sensitive client intake forms, legal aid resources, safe housing directories, confidential counselor notes, policy documents that are constantly changing, a whole network of referral partners. An agent leveraging an enterprise knowledge graph wouldn't just pull up a document based on a keyword. No. It could understand the intricate connections between a specific client's immediate safety needs, their legal status, available local housing options, maybe even previous intervention strategies that worked, or the availability of a certain type of therapist. This leads to far more informed, integrated, and personalized support, doesn't it? That kind of holistic understanding delivered autonomously. That's genuinely transformative for critical situations. ###C. Building your first agent with the Agent Designer UI. Leveraging your prompt engineering skills. And the best part, getting started with AgentSpace doesn't mean you suddenly need to become a full-stack developer overnight. It includes this remarkably intuitive no-code interface called Agent Designer, which is honestly a fantastic entry point, especially for those of you with Python experience who are looking to expand your AI toolkit. Without a super steep learning curve and totally new frameworks, you can access AgentSpace directly through the Google Cloud Console. You just navigate to AI applications, select AgentSpace. It's pretty straightforward, designed to get you building quickly. Once you're in the Agent Designer, you'll immediately see how incredibly easy it is to connect your agent to various services. This includes other Google tools like Calendar and Google Mail, sure, but also a really robust selection of crucial third-party platforms. Think Workday, Jira, Outlook, ServiceNow. This extensive interoperability is absolutely key to creating a truly powerful agent, one that can actually interact with and influence your existing organizational ecosystem.
That service integration sounds like a total game changer for practically any organization, really. It just removes so many of those traditional integration headaches. And for our listeners' specific goal supporting domestic violence crisis response, this capability seems particularly vital. Could you maybe elaborate a bit on how connecting to, say, a CRM or internal communication tools could dramatically enhance an agent's utility in such a sensitive environment?
Oh, absolutely. It's huge. Just imagine connecting an agent to your crisis center's CRM. It could pull up a client's history, with their explicit consent, of course, and following strict privacy protocols, allowing for much more informed case management. Or linking it to internal communication tools for streamlined team coordination. Maybe it could alert specific counselors based on the nature of a new intake automatically. You could even connect it to external referral networks to instantly access the latest partner info for legal aid or emergency shelter. The agent isn't just some isolated tool anymore. It becomes an integrated, intelligent part of your organization's digital workflow, really amplifying human efforts where they're needed most. Now, this is where your prompt engineering expertise truly shines. When you're building your agent and Agent Designer, you'll interact with a prompt gallery. And while Google offers a really solid gallery of pre-made prompts for common tasks like analyze data, book time off, chat with content documents, create Jira ticket, the real power for you. With your deep prompt engineering background lies in understanding the underlying design principles of these prompts. And then crafting your own highly specialized ones, tailored concisely to specific organizational needs. This isn't about just picking a prompt from a list. It's about creating your own custom prompts. Just like how you might customize a writing assistant prompt to help me write concise sentences, but, on a much grander scale. Instead of just designing a conversational bot, you're designing the very mindset, the mission, the behavioral parameters of an autonomous agent. Imagine crafting a prompt like this. You are a compassionate, highly trained crisis support agent. Analyze the provided intake summary for immediate safety risks. Identify the 3 most relevant local support services based on the client's specific needs. Then draft a secure, empathetic follow-up message to the client. Ensure strict adherence to confidentiality protocols, use a tone that is empowering and trauma-informed, and flag any information requiring immediate human review. That's next-level prompt engineering, isn't it? You're not just giving it instructions, you're kind of imbuing it with a persona, a purpose, and critical ethical guidelines.
That's an incredibly powerful example. It really shows how prompt engineering evolves from just, crafting simple queries to truly shaping an agent's cognitive and ethical parameters, which is huge. And it brings us back to that question I raised earlier. How can we thoughtfully design these custom prompts and leverage those advanced features, like integrating private knowledge graphs, to make sure our agents are not only efficient, but also deeply empathetic, context-aware, and ethically sound, especially when dealing with sensitive, high-stakes situations and crisis response? What are some concrete strategies for embedding those values directly into the prompt and the agent's architecture?
That's a vital point, absolutely. And it's where a prompt engineer's skills move from just craft to true architecture, really. So to address that, AgentSpace offers a number of advanced capabilities for deeper customization and ethical embedding. For instance, you can integrate with data stores to securely store your own custom, proprietary, and highly sensitive data. This ensures your agents have access to a verified and controlled knowledge base. That's critical. There's also the option to integrate with Google Knowledge Graph for general knowledge, sure. But more importantly, for sensitive applications, your own private knowledge graph. This is crucial because it allows you to build in very specific contextual rules and verified information that directly informs the agent's ethical decision-making and ensures compliance with protocols. You're effectively building a digital rulebook and compass for your agent. And then, once your agent is ready, you can expose it to the web via a secure web interface and monitor its performance and usage patterns with integrated analytics, allowing for continuous refinement and crucial oversight. Okay, now for those of you who are really comfortable in your Python environment, living in the terminal, here's where it gets really interesting. This is where the concept of agentic design extends directly into your daily coding workflow. The command line interface, the CLI, which has long been this bastion of precise commands and scripted automation, it's undergoing a profound transformation, seriously. It's no longer just about executing simple scripts. It's evolving into an intelligent, collaborative workspace.
That's a pretty bold claim, For many developers, the CLI is synonymous with deterministic, explicit actions. You type a command, it does exactly that. How exactly are these new AI agent CLIs transforming it beyond just simple command execution? What's the fundamental shift in how developers will interact with their terminal when an agent is involved? What does that feel like?
It's a complete paradigm shift, honestly. We're seeing the emergence of this whole new class of tools, AI agent CLIs. And these tools go way beyond merely executing commands you type. They understand natural language, not just keywords or flags. They maintain context about your entire code base across multiple files, multiple directories. And critically, they can perform complex, multi-step tasks to automate significant chunks of the development lifecycle. This is a total game changer for how developers interact with their projects. You move from issuing individual, isolated commands to delegating entire, nuanced workflows. Imagine telling your terminal, hey, fix this bug across these 5 files, update the test, and make sure it follows our style guide. And it just does it, explaining its process as it goes. ###Shibi, a glimpse into the world of specialist agent CLIs. And there's this vibrant, rapidly evolving ecosystem forming with several leading players in this space already. Now, while many tasks can technically be accomplished by different agents, the key differentiator often lies in the quality, the efficiency, the nuance of the results, and also their particular strengths and architectural philosophies. Each has its own flavor. Let's look at a few examples, because each one brings its own unique set of superpowers to the table. We're moving beyond just using an AI tool. We're talking about choosing the right specialist for the right task. Building a team. Okay, first up, we have the Claude CLI, or Claude Code from Anthropic. This agent is really engineered as a high-level coding agent and has this deep, holistic understanding of a project's architecture. Its core strength is its agentic nature, allowing it to create a pretty sophisticated mental model of your entire repository. This deep understanding is absolutely vital for complex, multi-step tasks that require a broad, coordinated view across many files and modules. The interaction style with Claude is highly conversational. It feels almost like a genuine pair programming session. It explains its detailed plans before executing, which is incredibly helpful, especially for pros working on large-scale projects. Things involving significant refactoring or implementing features with broad architectural impacts. For instance, you could tell it, okay, our current user auth relies on session cookies. Refactor the entire code base to use stateless JWTs. Update the login and logout endpoints, the middleware, the front-end token handling, everything. Claude will then meticulously read all the relevant files, outline its coordinated plan, and then perform the necessary changes, explaining its process the whole time. Or you could point it to some complex module and ask it to generate comprehensive ts.comments for every function, explaining its purpose, parameters, return value. And it understands the context of the whole project to do that accurately. Under the hood, Claude CLI functions as this highly specialized coding assistant. It has inherent tools for core dev tasks like file ingestion, comprehensive code structure analysis, intelligent edit generation. It also has deep integration with Git for direct branch and commit management. It can literally commit its own changes. And crucially, its extensibility is mediated by something called the Multi-Tool Control Protocol, or MCP. Think of MCP as like a standardized API, or maybe a common language that these agents use to speak to other systems or custom tools you build. It lets you define and integrate custom tools, maybe private APIs, internal database queries, specific linters, effectively positioning you as the arbiter of its functional scope, making sure it interacts securely and precisely with your specific environment. Okay, next, let's talk about the Gemini CLI from Google. This one is remarkably versatile, and it's open source, designed for both power and accessibility. It really stands out because it's powered by the advanced Gemini 2.5 Pro model, which boasts this massive 1 million token context window, basically. It can remember and process a huge amount of information at once. And importantly, it has multimodal capabilities. It can process both images and text simultaneously, which is wild. Its open source nature, along with the generous free tier and its built-in reason and act loop, make it transparent, controllable, and just an excellent all-rounder for a broad audience, from hobbyists to enterprise developers, especially if you're already in the Google Cloud ecosystem.
That reason and act loop. That sounds like a fundamental concept in this agentic AI space. Could you expand on that a bit? What exactly does it mean for an agent to reason and act? And how does that iterative process actually manifest itself in Gemini's capabilities? What does it do?
Absolutely. Yeah, it's a core distinction. The reason and act loop is essentially the agent's internal OS for problem solving. It means the agent doesn't just act once and stop. No. Instead, it observes its environment or receives your prompt. Then it reasons about the current state and the goal you've set. It plans a step, executes that step using its available tools like file system access or running a shell command, and then it observes the new state, the result of its action, to reason about the next step. It's this continuous iterative cycle of sensing, thinking, and doing, which allows it to adapt and course correct towards a complex goal. It's not just a one-shot deal. For example, its multimodal capabilities are incredibly impressive. You could literally give it a screenshot of a web component from a design file, just an image, and instruct it. Write the HTML and CSS code to build a React component that looks exactly like this. Make sure it's responsive. It literally sees the image and then generates the precise code. It's amazing. Or, leveraging its built-in Google Cloud integration, you could command it. Find all GKE clusters in the production project that are running versions older than 1.28. Then generate a gcloud command to upgrade them one by one. This kind of intelligent operational automation is a huge time saver, right? And significantly reduces manual error. And through that multi-tool control protocol, MCP, it can integrate with enterprise tools too. Imagine providing Gemini with a custom tool called Get Employee Details that connects to your company's internal HR API. Then you prompt it. Draft a welcome document for our new hire. First, use the Get Employee Details IDE 90210 tool to fetch their name and team. Then populate the welcome template.md with that information. It fetches the data using your tool, then drafts the document. Seamless. It can also handle large-scale refactoring, like replacing a deprecated logging library in a big Java code base with a new structured framework across multiple files, demonstrating its ability to orchestrate those complex multi-file changes. Gemini CLI comes equipped with a robust suite of built-in tools for interacting with its environment. Things like file system operations for reading and writing, a shell tool for running any command, web fetching, searching for grabbing external info. It can read multiple files at once, which is crucial for code-based understanding. And it uses a memory tool to save information across sessions. All of this is built on a secure foundation, using sandboxing to isolate the model's actions, and MCP servers to safely bridge to your local environment or other APIs, ensuring both power and security. Now, for your work with domestic violence crisis response, imagine an agent like Gemini. It could process a complex flowchart or maybe a diagram of an intake process, using its multimodal capabilities to understand that visual representation. It could then generate the Python code to automate key steps, integrating seamlessly with your existing cloud resources for data storage and processing, all while ensuring compliance with privacy regulations. That's a significant leap in efficiency and accuracy, isn't it? Helping you streamline critical support workflows and focus human expertise where it's truly most needed. Then there's Hater. This is an open-source AI coding assistant that acts like a true pair programmer. Its defining feature is its directness and deep integration with Git. It works directly on your files, applies edits, runs tests to validate those edits, and then automatically commits every successful change straight to Git. It's also model agnostic, which is great. It gives you complete control over cost and capabilities by letting you choose your preferred LLM backend. Its Git-centric workflow makes it perfect for developers who value efficiency, granular control, and a transparent, auditable trail of all code modifications. With Aider, you can literally do test-driven development, TDD, right there at the command line. You can say, create a failing test for a function that calculates the factorial of a number. After it writes the test and you see it failing, your next prompt is simply, okay, now write the code to make the test pass. Aider implements the function, runs the test again to confirm it passes, and then commits the change. Boom. It's fantastic for precise bug squashing, rapidly iterating on new features, or even updating dependencies across your whole project, ensuring every single change is verified. And finally, we have the GitHub Copilot CLI. This basically extends the popular AI pair programmer you might already be using in your editor directly into the terminal. Its primary advantage is its native, deep integration with the GitHub ecosystem. It truly understands the context of a project within GitHub, not just the files sitting on your local machine. Its agent capabilities allow it to be assigned a specific GitHub issue. It can then work on a fix and even submit a pull request for human review, all from the command line. This means it can handle automated issue resolution, like a manager could assign a bug ticket, and the Copilot agent could check out a new branch, write the code, run tests, and submit a pull request referencing the issue, all without manual developer intervention. It's also great for repository-aware Q&A. A new developer could ask, hey, where in this repository is the database connection logic defined, and what environment variables does it need? Copilot CLI uses its awareness of the entire repo to give a precise answer with file paths and relevant details. It even works as an incredibly helpful shell command helper when you're unsure about complex Git commands or obscure system utilities. Super handy.
So what we're really seeing across these powerful CLI agents, it seems, is this spectrum of specialization. And it fundamentally redefines the developer workflow, doesn't it? From Claude's architectural mastery for those big refactors and its deep contextual understanding, to Gemini's multimodal versatility and that iterative reason and act loop for everything from UI generation to cloud automation. Then Aider's TDD-centric efficiency and commit-level precision, and Copilot's seamless GitHub integration for issue resolution and repository-aware insights. The key insight isn't just that these tools exist, but that successful agentic development really requires choosing the right specialist for the right task, and often orchestrating several of them together like a team. It's about designing your development process around a team of intelligent collaborators, offloading those incredibly time-consuming and context-heavy tasks, which frees you up to focus on the unique high-level challenge of your project, like ensuring the privacy, the ethical handling, and the compassionate application of sensitive data in a crisis response system, those uniquely human parts.
That's such a crucial point about choosing the right tool for the job. And with all these powerful new tools emerging so quickly, how do we objectively compare them? How do we truly understand their capabilities and, maybe more importantly, their limitations? That's where Terminal Bench comes into play. This is a novel and, I think, increasingly important evaluation framework. It's specifically designed to assess the proficiency of AI agents in executing complex tasks within a command line interface environment.
This kind of standardized benchmark sounds essential for navigating such a rapidly evolving landscape. It moves beyond just anecdotal evidence. What were the key motivations behind developing Terminal Bench? And what specific aspects of agent performance does it aim to measure? Is it just about, did it complete the task, or is it something more nuanced?
Oh, it's definitely more nuanced than just pass-fail. The developers behind Terminal Bench identified the terminal as an optimal environment for AI agent operation, mostly due to its text-based sandbox nature, which makes it ideal for consistent, repeatable, and secure testing. You can control the environment perfectly. The initial release, Terminal Bench Core V0, comprises an impressive 80 manually curated tasks, and these span various practical domains, scientific workflows, data analysis, general system administration, real-world stuff. These tasks are designed to be complex and multi-step, really pushing an agent's reasoning and execution capabilities. Now, to ensure equitable comparisons, they developed a minimalistic agent called Terminus. This serves as a standardized test bed for different language models and agentic frameworks, leveling the playing field. The framework itself is designed for extensibility, allowing for easy integration of diverse agents through containerization or direct connections. And future developments include enabling massively parallel evaluations, so you can test many agents quickly. So why does Terminal Bench matter to you? Well, for developers like yourself, it's an invaluable guide. It helps you understand the quality, the efficiency, the nuance that truly differentiate these powerful tools. It provides empirical data, actual numbers, to inform your choices when building robust, reliable AI solutions, ensuring you select the agent that best fits the demands of your critical projects, like those supporting domestic violence crisis response, where performance and accuracy are absolutely non-negotiable. Okay, so what does this all mean for you? As someone who's already proficient in prompt engineering, building sophisticated AI solutions, how do these agents actually achieve this level of reasoning and planning we keep talking about? Well, at the cognitive core of every single intelligent agent lies its large language model, its central mind, so to speak.
And it's really important to clarify up front, isn't it, that when we say mind, we're speaking metaphorically here. These LLMs aren't conscious. They aren't thinking in a human sense, not at all. Instead, their reasoning is what we call an emergent property. It comes from incredibly sophisticated pattern matching, information retrieval, and probabilistic calculation processes. Models like DeepSeek are quite explicit about this, pointing out they excel at structured computation, not conscious thought. Understanding that distinction is absolutely crucial for setting realistic expectations and designing effective, reliable agents.
That's an absolutely vital clarification, yes. So with that important caveat in mind, this LLM is not merely a sophisticated text generator. It's more than that. It serves as the foundational reasoning engine, the very mind, in that emergent computational sense that empowers the agent. It allows it to interpret goals, make decisions based on context, formulate plans, and interact with its environment. It's where that capability for dynamic intelligence resides.
Exactly. And understanding these internal reasoning mechanisms, the structured computational process, it's no longer just some academic exercise, right? It's become a critical necessity for developing the next generation of robust, reliable, and effective agents. It's how you move from merely prompting for text to truly engineering agent behavior, allowing you to build systems that are not just reactive, but genuinely thoughtful and capable within their defined parameters, of course.
Building on that, we've actually got some fascinating insights directly from the LLMs themselves, explaining how they approach what we perceive as reasoning. It's quite illuminating. Let's break down their internal thought process step by step, because understanding these steps is invaluable for designing better, more reliable agents. Okay, the first step, universally across models like Gemini, ChatGPT, Grok, DeepSeek, it's deconstructing the prompt. They all begin by meticulously analyzing your prompt. To understand the core task, pinpoint key concepts, identify any explicit constraints you've given, and infer the underlying intent. They're essentially dissecting your request to get to its absolute essence, much like a meticulous project manager reads a brief, And this first step, this is your moment as a prompt engineer. This is where you shine. The better you define the core task, pinpoint key concepts, and articulate explicit constraints, the better the agent's foundational understanding will be. It starts here. For a domestic violence crisis agent, this means being incredibly precise about what constitutes an immediate safety risk or what confidentiality protocols actually entail, or what a trauma-informed tone requires in its language. Your clarity directly translates into the agent's initial grasp of the problem and its ability to act ethically and effectively. Following prompt deconstruction, the models move into information retrieval and synthesis, or sometimes called activating relevant knowledge. Now, this isn't a simple database search in the way a computer engineer might traditionally think of it, not quite. Instead, it involves activating relevant parts of their massive neural network, recognizing patterns, making connections learned during their vast training. Gemini, for example, explicitly mentions how its transformer model excels at recognizing relationships and patterns between words and ideas, drawing on its vast internal knowledge base.
So it's not just pulling isolated facts, is it? It's actively seeing how those facts relate to each other and to the current problem you've given it. That definitely goes beyond simple retrieval. For our listener, working in crisis response, this ability to synthesize disparate information sounds absolutely critical. What might that look like in practice for an agent assisting with a domestic violence crisis call, for example?
Exactly. Imagine an agent synthesizing all these disparate pieces of information, a client's narrative from the call, a comprehensive database of local legal aid services, maybe historical data on successful interventions for similar situations, even real-time shelter availability from another system, and connecting all those dots to identify the most effective personalized next steps for that specific person. This complex pattern recognition is really at the heart of insightful AI assistance. allowing it to go beyond just retrieving facts to actually drawing connections and forming a coherent understanding that supports a comprehensive action plan. Okay, the third crucial step is choosing a reasoning method, or formulating a mental model, or sometimes called building the chain of thought. Here, the models detail how they select appropriate reasoning methods, things like deduction, going from general rules to specific conclusions, induction, specific examples to general rules, causal reasoning, identifying cause and effect, or analogical reasoning, drawing comparisons. They then organize the information into a logical structure, simulating a step-by-step thinking process, much like a human might, but obviously through a computational lens. Kimi provides a great concrete example for this. Using the simple question, which is larger, 3 years or 4 in ascent? It meticulously walks through its internal process. First, input preprocessing. Then, problem identification. Then strategy selection. It chooses direct evaluation over logarithms because the numbers are small. Then knowledge retrieval, recalling powers like 3 to 9, 4 to 9.16. Then computing 3 years, 4 to 64. Then execution, then verification, and even metacognitive reflection on potential edge cases. This illustrates that precise, multi-stage internal process that underpins what looks like reasoning.
That chain of thought concept is truly fundamental, isn't it? It's how these models can break down really complex problems, like navigating intricate domestic violence support protocols or generating a multifaceted support plan, breaking them down into manageable, logical steps. And as prompt engineers, we can actually guide this chain by explicitly asking the agent to think step by step, or maybe to explain its reasoning. That makes the whole process more transparent, more robust, and more reliable, especially for these high-stakes applications. You're essentially teaching the agent how to show its work, which builds trust.
Right. Now, the fourth step in this internal process is generating the response. This is where the models take all that internal reasoning and construct the final output you see. They generate sentences, apply any specified formatting rules like using Markdown or adopting a particular tone you requested, and they perform an internal review for accuracy and coherence based on the prompt's requirements. They're essentially predicting the most probable sequence of words to form a clear, natural-sounding, and contextually appropriate response. And finally, we have review and refinement, sometimes called metacognitive reflection. Models like Grok and Kimi explicitly mention this internal review process, where they evaluate their own confidence scores, identify potential edge cases or ambiguities in their own output, and iteratively refine the output for clarity, completeness, and adherence to the prompt. They're essentially self-editing, trying to make their output as optimal as possible before giving it to you.
And this internal review, while it sounds incredibly sophisticated, it's still fundamentally a computational process. As you mentioned earlier, DeepSeek offers that really important nuanced perspective, clarifying that its process is a sophisticated pattern matching, information retrieval, and probabilistic calculation process. It's structured computation, not conscious thought. Its reasoning, as it explains, is an emergent property that comes from statistically predicting coherent, logical, and contextually relevant responses based on its training data. So while it appears to reason, it's achieving that through incredibly advanced statistical prediction and pattern matching, not human-like consciousness. It's a crucial distinction.
Okay, so understanding these internal steps from deconstruction to reflection and keeping in mind that critical distinction about emergent reasoning, it makes you an even better prompt engineer. You're not just writing a query anymore. You're helping to shape the very cognitive process of the agent in a way. You're guiding its interpretation, its information use, its reasoning path, and its output structure. That's incredibly powerful and allows you to build agents that are not only effective, but also deeply aligned with your intent, especially crucial for sensitive critical applications like crisis response. All right, let's shift gears now and talk about how this whole agentic revolution impacts your role as a developer, day to day. You've probably experienced what some people call vibe coding, right? Using LLMs for quick drafts, outlines, maybe prototypes, just to overcome that dreaded blank page problem. And it's fantastic for rapid innovation, exploring new APIs, really getting past that initial hurdle of starting from scratch. It's certainly improved developer velocity for many people.
Yeah, vibe coding is a great term for that initial burst of productivity. Getting the ball rolling, it's been incredibly useful for speeding up development, no doubt. But what you're hinting at here sounds like a much more profound shift. Are we moving beyond just getting AI to generate a first draft? What does true team collaboration with agents really entail? What does that look like?
Exactly. We're moving way beyond that. The industry is now shifting towards a much more integrated and powerful paradigm. We're talking about augmenting human creativity with specialized coding agents that act as tireless, intelligent team members. This isn't just about getting a quick draft anymore. It's about a deeply integrated partnership, a real team. And this shift is clearly validated by industry leaders. Alphabet CEO Sundar Pichai noted that at Google, over 30% of new code is now assisted or generated by our Gemini models, fundamentally changing our development velocity. Microsoft made a similar claim, highlighting that this signals the true frontier isn't replacing developers. No, it's profoundly empowering them.
Right. This shift signals that the true frontier is definitely not about replacing developers, but about augmenting and empowering them, making them more effective. The goal seems to be this augmented relationship where humans retain the critical architectural vision, the creative problem-solving, the why, while agents handle the specialized, scalable, and often repetitive tasks, like generating boilerplate, writing comprehensive tests, creating documentation, even conducting initial code reviews, the how. This means you can focus your valuable skills on the most impactful, nuanced, and human-centric parts of your work, rather than the more mechanical ones. It's really about leveraging the best of both human and AI capabilities working together.
So how do we organize this new human-agent partnership effectively? How do we make it work? Well, we have a robust framework for organizing a human-agent team. It's based on 3 foundational principles, designed to maximize both efficiency and, crucially, control. First, there's human-led orchestration. This is paramount. In this setup, you are the team lead. You are the project architect. You are the final decision maker, period. You orchestrate the entire workflow, setting the high-level goals, exercising the final judgment on any agent-generated output. Agents are powerful, yes, but they are supportive collaborators. They're there to amplify your vision and execute your strategic direction, not replace it. You're the boss.
That emphasis on human-led orchestration is so critical, especially when developing for sensitive areas like crisis response. You need that accountability. It ensures accountability and keeps human values right at the core. But it also implies a significant responsibility for the human lead, doesn't it? How does the second principle, the primacy of context, support this human leadership and make sure the agents can actually act as effective team members?
It's absolutely foundational. You can't skip this. Second is the primacy of context. This is non-negotiable. An agent's performance is entirely dependent on the quality and completeness of its context. Garbage in, garbage out, amplified. A powerful LLM, even one like Gemini 2.5 Pro, with poor or incomplete context, it's effectively useless, maybe even dangerous. So your responsibility is to meticulously assemble the perfect briefing for your agent team member. This includes providing the complete, relevant code base, any essential external knowledge like documentation or API definitions, and a crystal clear human brief outlining the specific goals, detailed requirements, even style guides. There's no black box context retrieval here. You maintain full, transparent control over exactly what the agent sees and works with. And the third principle is direct model access. To achieve state-of-the-art results, your agents must have direct access to the frontier models. We're talking models like Gemini 2.5 PRO or Claude Opus 4, the best available, using less powerful models or routing requests through intermediary platforms that might truncate context or add unnecessary layers. That will inevitably degrade performance and quality. You lose fidelity. The framework is built on creating the purest possible dialogue between you, the human lead, and the raw, cutting-edge capabilities of the underlying model, ensuring the agent operates at its absolute peak potential.
Okay, so if we connect this to the bigger picture, these principles, human-led orchestration, the primacy of context, and direct model access, they're really all about maintaining absolute control and ensuring the agents truly amplify your intent, your goals. This is just paramount when you're building solutions for sensitive areas like domestic violence crisis response, where even subtle misinterpretations or lack of context could have serious real-world consequences. Your architectural ownership and meticulous context curation become critical, not just for efficiency, but for ethical and effective AI, guaranteeing that the solutions you build are not just functional, but also profoundly responsible and aligned with the deep needs of the users.
Right. So within this powerful framework, you, the human developer, you are still the orchestrator. You're the central intelligence, the ultimate authority, guiding the overall direction. The agents, then, they become your highly specialized augmented team members, each with a specific role. The first component supporting this team is the context staging area. Think of this as a dedicated temporary workspace, maybe just a simple directory like task context within your project. This is where you prepare those task-specific briefings we talked about. You'd place markdown files there for detailed goals, relevant code snippets, necessary documentation, any other crucial info, ensuring your agents get a complete and perfectly accurate picture for every single task. No ambiguity. Okay, now for your actual specialist AI teammates. These aren't necessarily separate applications you launch every time. Rather, they are conceptual personas you invoke within the LLM. Through carefully crafted role-specific prompts and contexts that define their expertise and their specific mission for that task. First, we have the scaffolder agent. You can think of this one as the implementer. Its purpose is to write new code, implement features, or create boilerplate based on the detailed specifications you provide in the context. Your invocation prompt for this agent might look something like, "You are a senior software engineer. Based on the requirements in 01 brief f.md and the existing patterns in OE2 code, implement the feature described in the brief, ensuring adherence to best practices and our project's coding standards." Imagine using this agent to quickly spin up the backend for a new data logging system for your crisis response app. Your prompt could be something like, "You were a senior Python engineer. Based on the requirements in crisisrequirements.md and existing patterns in start support modules, implement a new module to securely log incoming crisis call metadata. Ensure compliance with privacy regulations like HIPAA and GDPR, and integrate it with our existing database schema defined in dbschema.sql. This accelerates development significantly while embedding those critical requirements right from the very start. Next, there's the test engineer agent. This is our quality guard. Indispensable. Its purpose is to write comprehensive unit tests, integration tests, maybe even end-to-end tests for new or existing code, ensuring robustness and reliability. An invocation prompt could be, "You are a quality assurance engineer specializing in Python testing. For the code provided in 02 code, write a full suite of unit tests using PyTest. Cover all identified edge cases outlined in 03 edgecases.md and adhere strictly to the project's testing philosophy and target 95% code coverage."
Yeah, this role is absolutely vital for mission-critical applications where reliability just cannot be compromised, ever. For that colleguard.py module we just discussed, how specifically could the test engineer agent enhance confidence in its operation, especially given the highly sensitive nature of the data it's handling?
This is indispensable, truly. For that colleguard.py module, you could prompt something like, "For the colleguard.py module provided in Scark logging, write a full suite of unit tests using PyTest. Cover data integrity checks, edge cases like malformed input or null values, potential concurrency issues that might arise during high call volumes, and crucially, write specific tests for ensuring compliance with privacy regulations regarding data encryption, access controls, and data retention policies as specified in privacypolicy.md. Make sure to simulate various valid and invalid input scenarios." This level of automated, rigorous testing is just indispensable for reliable, trustworthy crisis response systems. Then we have the documenter agent, our scribe, often overlooked but so important. Its purpose is to generate clear, concise, and accurate documentation for functions, classes, APIs, or even entire code bases. A prompt might be, "You are a technical writer specializing in API documentation. Generate comprehensive markdown documentation for the API endpoints defined in the provided Flask code module, appendix.py. Include clear request response examples, JSON for each endpoint. Explain every parameter, including data types and constraints, and provide basic usage examples in Python using the request library." Clear, consistent documentation is absolutely crucial for team collaboration, right? Especially in a nonprofit setting where volunteers or new staff might frequently join or rotate roles. Turnover can be high. Let an agent handle the first draft for your internal APIs, data schemas, or user guides. Ensuring consistency and saving valuable human time that can be redirected to direct support or higher-level tasks. We also have the optimizer agent, your refactoring partner. Its purpose is to rigorously analyze existing code and propose performance optimizations or code refactoring opportunities, things to improve readability, maintainability, and overall efficiency. You might prompt it. Analyze the provided Python code, dataprocessor.py, for any performance bottlenecks, potential security vulnerabilities like injection risks or insecure dependencies, or areas that could be refactored for improved clarity, modularity, and adherence to modern Pythonic conventions, PP8 type hinting. Propose specific changes with detailed explanations for why they are an improvement and their expected impact. Focus on changes that don't alter functionality. And finally, the process agent, or maybe the code supervisor. This one's interesting. This agent performs an initial detailed critique of your code first, identifying potential bugs, style violations, according to your project's linters like Flake8 or Pylint, and logical flaws. Then it does something cool. It reflects on its own critique. It emphasizes the findings, prioritizes the most critical issues, and provides a high-level, actionable summary specifically for you, the human developer. The invocation prompt might be something like, "You are a principal engineer conducting a rigorous code review. First, form a detailed critique of the stage changes described in 01 changes.md against the codebase in 02 code, focusing on correctness, maintainability, security, performance, and adherence to our style guide, styleguide.md. Second, reflect on your critique to provide a concise, prioritized summary, max 5 bullet points of the most important feedback, including suggested next steps for the developer."
Wow. These specialized agents, when orchestrated effectively by a human lead, they truly allow you to tackle complex, multifaceted projects for organizations like domestic violence crisis centers with unprecedented speed, quality, and rigorous oversight. It's a whole new level of rigor. They help ensure that your solutions are not just functional, but robust, well-tested, maintainable, and even initially reviewed for potential issues before a human spends time on it. This structured approach really helps ensure no critical detail is missed, which is paramount when lives can genuinely depend on the reliability and ethical operation of your systems. It's like building a fortress, not just a house, with your augmented team. Really solid. #, DP, practical implementation and leading your augmented team.
So you're not just a coder anymore, are you? You're an AI team lead, which is pretty cool. Let's talk about the practicalities. How do you set up and effectively lead this augmented team in your daily development workflow? First, here's a concise setup checklist to get you operational. 1. Provision access to frontier models. You need API keys. Get them for at least 2 leading LLMs like Gemini 2.5 Pro and Claude 4 Opus. Why 2? Well, it gives you comparative analysis capabilities, lets you pick the best model for a specific task, and hedges against any single platform limitations or downtime. And crucially, remember to manage these credentials as securely as any other production secret. Treat them like gold. 2. Implement a local context orchestrator. Don't just rely on ad hoc scripts. Use a lightweight CLI tool or a local agent runner. These tools should let you define a simple configuration file, maybe a context.toml in your project root. This lets you precisely specify which files, directories, or even URLs to compile into a single comprehensive payload for the LM prompt. This ensures you retain full, transparent control over exactly what the model sees on every single request. No magic context stuffing. 3. Establish a version-controlled prompt library. This is key for consistency. Create a dedicated prompts directory right within your Git repository. Store your invocation prompts for each specialist agent reviewer.md, documenter.md, tester.md as clear markdown files. Treating your prompts as code allows your entire team to collaborate on, refine, and version these crucial instructions over time, ensuring consistency and continuous improvement. 4. Integrate agent workflows with Git hooks. You can automate parts of your quality assurance rhythm. For example, configure a pre-commit hook to automatically trigger the reviewer agent on your staged changes. The agent's critique and reflection summary can then be presented directly in your terminal before you finalize a commit. This gives you immediate feedback, baking quality assurance right into your core development process, making it proactive, not just reactive. Okay, now beyond the setup, here are the principles for leading the augmented team that will really ensure your success. First, maintain architectural ownership. Your role is to set the strategic direction. Own the high-level architecture. You define the what and the why of the project. Use your agent team to accelerate the how. You are the final arbiter of design, ensuring every component aligns with the project's long-term vision, quality standards, and critically ethical guidelines. Second, master the art of the brief. Remember that primacy of context. The quality of an agent's output is a direct reflection of the quality of its input briefing. Think of your prompt not as a simple command, but as a complete, meticulously prepared briefing package for a new, highly capable team member. It needs to be clear, unambiguous, and comprehensive for every task. Be explicit. Provide examples. Define constraints carefully. Third, act as the ultimate quality gate. This is non-negotiable. An agent's output is always a proposal, never a command to be blindly accepted. Treat the scaffolder's code, the test engineer's tests, the reviewer agent's feedback as powerful signals, valuable input. But you are the ultimate quality gate. Apply your domain expertise, your project-specific knowledge, your human judgment to validate, challenge, and approve all changes. You are the final guardian of the codebase's integrity and ethical alignment. And fourth, engage in iterative dialogue. The best results emerge from conversation, not monologue. If an agent's initial output is imperfect, and it often will be, don't just discard it. Refine it. Provide corrective feedback, add clarifying context, prompt for another attempt. This iterative dialogue is crucial, especially with agents like the process agent, whose reflection output is designed to be the start of a collaborative discussion, not just a final report. It's about teaching and refining, just as you would with a human team member.
Absolutely. That iterative dialogue and your role as the ultimate quality gate, they were just so crucial, Host. Especially in these high-stakes applications like supporting domestic violence crisis response, it ensures the AI suggestions and actions are always aligned with the specific, nuanced needs of the situation, where sensitivity, accuracy, and human oversight are completely non-negotiable. Your expertise provides that essential human check, that ethical compass on the AI's capabilities, ensuring both efficiency and profound responsibility in every single action the system takes. It's about partnership, guided by human values. #, outro.
Wow. What an incredible deep dive that was. We really covered a lot of ground. We started with AgentSpace, that no-code gateway to building powerful reasoning agents. Then we explored the sophisticated world of CLI-based agents like Claude, Gemini, Aider, and GitHub Copilot, each offering unique strengths for your development workflow. We peeled back the layers a bit to understand how LLMs think, or rather, how they perform their multi-stage emergent reasoning processes. And finally, we laid out a pretty robust framework for you to lead your own augmented AI development team with specialized agents, turning you into an AI orchestrator, an AI team lead.
And you, with your strong Python background and your sophisticated prompt engineering expertise, you're now exceptionally equipped. Equipped to move beyond those static chatbots and architect truly intelligent autonomous solutions. Just think of the immense value you can bring to domestic violence crisis response organizations, profoundly enhancing their ability to serve and protect with more efficient, more accurate, and more empathetically designed systems. Your skills are truly poised to make a monumental impact in a critical area.
And as you embrace these agentic design patterns, as you step into this powerful new role as an AI team lead, maybe consider how your own ethical responsibilities deepen. It's a bigger role. When your AI agents are directly assisting vulnerable populations, what new considerations for safety, empathy, and data privacy arise in this autonomous paradigm? It's different than just a chatbot. And how can your already proficient prompt engineering skills be further refined, further sharpened? To embed those crucial human values, safety, empathy, privacy, fairness, directly into the agent's core reasoning, its planning, its action pathways, ensuring that the technology we build always serves humanity's best interest. Something to really think about. We hope this deep dive has given you a robust mental roadmap and sparked countless aha moments for your next projects. Until next time, keep exploring, keep building, and keep making that incredible, vital impact.